Good morning, students. So we have completed chemical properties of metals. Today we will discuss about some of the chemical properties of non-metals. So some general chemical properties of non-metals which we are going to discuss in today's video. The first property, chemical property, is electronegative character. So basically non-metals have a tendency to accept electrons and form negatively charged ions, and we call them anions. So anions are what? Ions carrying negative charge. So you can see here chlorine, this one, Cl, having what is its electronic configuration? 287, that is 17 electrons and protons. Now it can gain electrons. Okay, see, Cl plus electron, it will give Cl minus. In your book, half Cl2 is written. No, why Cl2 is written? This is also correct, but half Cl2 is more appropriate. Why Cl2 is written over there? Because you know that chlorine can exist in diatomic form. So that is why half Cl2 is there. So chlorine gain electron to form chloride ion. No, Cl plus electron gives out Cl minus. So that is why they are electronegative in nature. Electronegative means what? See, negative charge, it is carrying negative charge. So basically they are electronegative. Electronegative means what? Electron gaining. Okay, so this one you see electronegative. You know metals are electropositive. That means they are carrying positive charge. Metals carrying positive charge. Here non-metals carrying negative charge. So they are electronegative in nature. So non-metals are able to remove electrons. Right, you see. Non-metals are able to remove electrons from electropositive elements and acts as oxidizing agent. You turn the page, you can see the example. The example of hydrogen. Hydrogen is the only non-metal. Hydrogen is the only non-metal which can lose as well as gain electron. So you can see there, if hydrogen H2 gain electron, it is forming hydride ion. And if hydrogen lose one electron, then it will form hydride ion. No. So when gain electron, it form hydride ion, and when loss of electron occurs, it will form hydrogen ion. So this hydrogen can act both as an oxidizing as well as reducing agent. Now we are going to see the chemical properties of second chemical properties of non-metals, that is reaction with oxygen. So non-metals react with oxygen to give covalent oxides. Such oxides are either neutral or acidic in nature. How we are going to know that the following substance is acidic in nature? When we are going to use an indicator, right? We are going to take a litmus paper, and when blue litmus turns to red, that means it is acidic in nature. So acidic oxides of non-metals dissolve in water to form corresponding acids. As some of the examples are given, some common non-metals with oxygen are described below. Now see here, nitrogen is given. No, nitrogen is a non-metal. Now we are going to see that how nitrogen reacts with oxygen. So when nitrogen reacts with oxygen under different conditions, it is going to form 5 different oxides. Right? Now some of these are neutral and some of these are acidic in nature. Nitrogen, when reacts with oxygen, first it is forming nitrous oxide, which is neutral. Means it has no effect in the litmus paper. Hence it is neutral. Second one, it is going to form nitric oxide. It is also neutral. Third, dinitrogen trioxide. It is acidic in nature. When you dip litmus paper into this gas, means this gas is dissolved in some water, if we dissolve this gas in water and if you dip litmus paper into this substance, then what happen? The litmus paper turns to red. Hence we confirm that this substance is acidic in nature. Now nitrogen plus oxygen, what it will give? The fourth compound is nitrogen dioxide. This is also acidic in nature. Fourth one, when nitrogen reacts with oxygen, it is going to give us dinitrogen pentoxide. This is also acidic in nature. Okay, so all the 5 oxides of nitrogen are, first 2 are, that is nitrous oxide and nitric oxide, are neutral oxides, and the other 3, rest 3 are acidic oxides. Now you see N2O5 reacts with water to give nitric acid. Nitric acid, you know, that is HNO3 is nitric acid. Now you see carbon. When carbon reacts with oxygen, it forms 2 oxides, that is carbon monoxide and carbon dioxide. It is very easy. When oxygen is supplied limited, that means carbon is going to form carbon monoxide and it is neutral. So C plus O2 and oxygen in limited supply, what is formed? Carbon monoxide, which is neutral. And if you supply excessive amount of oxygen to carbon, it is going to form carbon dioxide, which is acidic in nature. Now this CO2, if you dissolve this carbon dioxide gas into water, carbonic acid is formed. This is H2CO3 is carbonic acid. Now if it ionizes, it will give H plus and HCO3 minus. Okay, so this is all about carbon, how carbon reacts with oxygen. Now let's see that how phosphorus reacts with oxygen. So when phosphorus reacts with oxygen, it will give 2 types of oxides. One is phosphorus trioxide and another one is phosphorus pentoxide. Now these both are acidic in nature. You see P4, you know phosphorus exists as tetraatomic. No, so P4 plus O2, and if you heat this, you will get phosphorus trioxide. This is acidic in nature. And again, if you heat P4 plus O2, it will give phosphorus pentoxide. This is also acidic in nature. Now if you add this phosphorus pentoxide into water, what is forming? You see phosphoric acid, H3PO4. Now in this bracket, what is written? Let's see. Most metals displace hydrogen from dilute acids. Okay. Acidic oxides of common non-metals, CO2, N2O3, NO2, N2O5. Just now we have discussed sulfur dioxide. We are going to discuss in the next topic. Neutral oxides of common non-metals, you see. Carbon monoxide is neutral in nature. And 3 more is there, that is water. You know water is neutral. N2O is neutral and NO, nitric oxide, is neutral. The oxides of non-metals are covalent compounds. This is also important. You know covalent compound is what you are going to study in higher classes. Covalent compounds are those compounds where the atoms share electrons and form bonds. Okay, the bond is formed between these elements. You see in this compound P2O5, all the bonds are formed by sharing the electrons of phosphorus and oxygen. So that is why they are covalent compounds. Now let's see about sulfur. Sulfur on burning in air form 2 oxides, sulfur dioxide and sulfur trioxide. You see S plus O2, if you burn this, you get sulfur dioxide, which is acidic in nature, and you will get SO3 also, which is acidic in nature. Okay, so when you add this SO2 to H2O, you will get H2SO3, that is sulfurous acid, and SO3 plus H2O, you will get sulfuric acid. Now you see hydrogen reacts with oxygen to form an oxide H2O. So H2O is called water, you know, and water is a neutral oxide. So when H2 reacts with oxygen, it forms water, which is neutral in nature. Now you see reaction with halogens. You see the reactions with halogens. Nonmetals react with halogen to give covalent halides. In pure state, the halides of nonmetal do not conduct electricity. Okay. So you see P4 plus Cl2, it will give phosphorus trichloride. These are what? These are halides. No, these are covalent halides. Then again, when 10 Cl2 will take, you will get phosphorus pentachloride. And when H2 plus Cl2 in sunlight, you will get hydrogen chloride. A few more examples are there. When sulphur reacts with fluorine at higher temperature, it will give sulphur hexafluoride. Okay. And when hydrogen chloride reacts with water, it will give hydronium ion, that is H3O plus Cl minus. Hydrogen chloride is a polar covalent compound. That means what? Polar covalent compound means here one partial charge will develop. Okay. As you are going to study this in higher classes. For now, just know that hydrogen chloride is a polar covalent compound. That is, the HCl bond has some ionic character. Okay. Ions means what? Negative and positive. Here also partial positive and partial negative charge develop. Cl, you know, Cl minus is there. So here partial negative charge will develop and H carrying partial positive charge. So pure HCl does not conduct electricity. Notice here that but an aqueous solution of HCl conducts electricity because of the presence of free ions, that is H3O plus and Cl minus due to the ionization of HCl. See here reaction with hydrogen. Non-metal reacts with hydrogen to form covalent hydrides. You see H2 plus S, it is forming hydrogen sulfide, which is covalent hydride. Okay. Now H2 plus N2, you know NH3, that is ammonia is formed, which is basic in nature. H2 plus O2, if you give electric spark to it, it is forming water, which is neutral. Now some hydrides of non-metals are given, which are either gases or liquid. You know, methane is a gas, ammonia is a gas, water is a liquid, like this. So hydrides of non-metals are more stable than those of metals. Okay. Now reaction with acids. You see, non-metals do not displace hydrogen from dilute acid. This is because non-metals are not able to give electrons for the reduction of H plus. See the example. S plus HNO3, it is forming sulfuric acid plus nitrogen dioxide and water. Okay. Now the two reactions of displacement reaction. Certain more reactive non-metals displace less reactive non-metals from their salt solution. So you see example, potassium bromide KBr plus Cl2. Okay. So chlorine will displace Br and takes the place of Br, and it is forming potassium chloride and bromine. Ki plus Cl2, KCl will form and iodine gas. So this is all about chemical properties of non-metals. Read the chapter, and if you have any problem, comment in the comment box. Thank you.